Okay, so there we go. They want you to take that expression, minus 2xy squared, and they want you to plug in 3 and plug in negative 4 for x and y, and work them out. Then you can use your calculator, of course. So let's take a look. So one of the things that you want to be able to do, if there's anything that would get you on this problem, it's changing to adding instead of multiplying. See how they're all multiplied in the beginning? See how it's minus 2 times x times y squared? There's no adding, subtracting, is there? It's all multiplying. So keep that in mind as you do the problem. Don't make anything added or subtracted. Even if something becomes positive, it's multiplied positive, not added. So what do we get then? We get minus 2 and then x and then y squared. I think it's helpful when you plug into an expression to put parentheses around the items you're plugging in. That might help you. So the 3 goes right there. The minus 4 right there. This is minus 6 times positive 16. See how it's times the 16? Not plus the 16. So it is minus 96. We good? All is well? So watch out for that. All right. So multiply those two expressions. See what you remember about multiplying letter. Right? What's the rule here? What do you do when you multiply expressions that have numbers and letters with powers? Yeah, you multiply the numbers in the front, you add the powers, huh? Remember that? Multiply the numbers in the front, add the powers. So negative 7 times positive 4 is negative 28. And then you add the powers on the same letters, huh? And this, what does it mean when a letter doesn't have a power showing? So 1, huh? So a to the 4, a to the 1 is a to the 5. And b to the 4, b to the 4 is b to the 8. Good? Easy? So keep track. How you doing? Every question's worth half a grade, 5%. So do you have 10% going so far? But that's the same problem. Can you read that okay?
Yes, sir.
Good. Does that background make it worse? Is that harder to see? Yeah, let me see. Just do it like this. Minus 5xy. Minus 5xy. Is that what it is? Minus 5xy over w to the squared. All squared. Oh, it's w. It's supposed to be. I'm sorry, I messed up the problem. Don't do that problem. It's entirely wrong. It's one little mistake. There we go. Let's try it now. All right, there it is. Try that one.
So 2 negatives is a positive, right?
Yeah, minus plus.
Really clear on. Tonight's election night, right? We're electing people that will take power. So I haven't seen anything. I have no idea how it's going. But I'm going to use it for my math analogy. So how many of these powerfully elected people will call me up and want to go to lunch with me? Or you?
None of them.
None of them. Why? Because I, and I assume you, are regular people. We're not power players, right? Power players go to lunch with power players, right? Powerful people with powerful people. I mean, usually I'm doing somewhat of an analogy. But so I'm doing this to help you remember. This is a power. So you want to think about in algebra like 2 levels of things. There's things in power, senators and congressmen and women, right? And then there's regular folks. So think about that in 2 levels, like society, sort of. Right? So that 5, that minus 5 there, is he a power player or a base? Base. He's not in power. The x and the y are base. The w is a base. The 5 is a power. This 5 here is a power player. The 5 that's on the w and the 2 out here. They're both power players, aren't they? So powers go to lunch with powers, right? Power players go to lunch with other power players. Powers interact with powers, not bases. So that's another way to help you remember the rule. Powers outside parentheses, what do? Don't just say they multiply. Be more specific than that. What do they multiply? Who do they go to lunch with? Other powers. So in other words, that 2 is not going to multiply the minus 5. That's beneath him. But it'll multiply his power, and his power, and his power, and this 5. Boom, 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 boom. Right? Powers with powers, not bases. Good there? So that's going to become 5 squared, x squared, y squared, w10. Yeah, we'll talk about the sign in just a minute. But everybody good so far? Does that make sense? You remember my analogy? It was on election night. Powers with powers, yeah.
Is that 5 still negative or changing?
We'll talk about it. But we good so far? So powers with powers. Powers with powers. So, and everybody has a 1 power that's not showing a different power, right? So powers with powers. Now, is it negative or is it positive? Yeah, let me help you with signs in general. Don't let the signs get confused with all the other rules. It's really simple. 2 negatives, positive. 3 negatives, negative. 4 negatives, positive, etc. Right? All you got to do with negatives is count if there's an even or odd amount of them. Don't worry about all the other fancy rules. Just say, what do you got here? 2 minus signs. So what is it? Positive or negative? It's positive. You don't have to write plus, but, it's positive, right? That good? Huh. We good? Just making sense? And you can leave that 5 squared, or probably they'll make it 25. So let me just...
25?
Yeah, both are right. Yeah, that's how they'll probably do it. Oh, is it bugging you that... Yeah. Now, be careful. They can do it either way on the test. Multiple choice. They'll probably do it this way, but this isn't wrong. It's just, they just left it 5 squared. 5 squared is 25, right?
Yeah.
And so don't grab none of the above because of that. That's what I'm saying on the exam Thursday. They're both good. I don't know which way it'll show.
So it's another way.
It's another way that's right. I think they will do the 25, if I remember right. I just made it a couple hours ago. So I think that's what they did, if I'm remembering right. Is that good? Everybody good with that? So, who do power players go to lunch with? Not me. They go with powers, right? Powers with powers. So remember that. It was election. All right, try that one. See if you can simplify that one. What do y'all do? What do you do on this kind of problem? Divide the numbers. 6 into 18. 3 times, or well, what, right? And then, what do we do with the powers? Subtract them, right? Powers that are vertical, subtract. So these 2 will just cancel. And what do the 6 and the 3 do?
We keep the one higher, 9.
Yeah. Y to the 3rd over 3?
Yeah. I always put 1.
How are we doing? Questions on that one? So we've had 4 questions. How you doing? How many have you gotten right?
Got 2 points.
Good. No questions on that one. Is that good? All is well? What if the higher power had been on the top? It was on the top. What if the higher power, what if there had been like y to the 3rd on the top and the higher one had been on the bottom?
Yeah, and it goes on the bottom.
Then the y to the 3rd would have been on the bottom. With the 3, there'd be nothing on the top, which means we put a 1. It would have been 1 over 3y to the 3rd, right? Everybody good with that? Wherever the higher power is, that's where the leftovers end up. So the higher one was on the top this time, so it ends up on the top. Okay, try that one. Y to the 9th, or I'll just make it bigger here. Y to the minus 9 over y. What you got to be clear on is what I just said. So negative powers. Oops. Thing is, my pen's just not working well. Negative powers first jump to to the other side. Then, oh, did I forget to write? Then become positive. So, meaning this guy is going to jump down. So don't try to add them, subtract them. Don't do any of that. So your first part, if you got a negative power anywhere in the problem, that's first. We're not going to add or subtract the numbers or do anything. We'll do that later. But first, negative powers are unhappy where they're at. Remember, that was my analogy. They're negative. They're at their job. They don't like their job. They're unhappy. They're going to jump to the other side. So they're negative. They're going to jump. And after the jump, then they're happy. Then they're positive. So let me ask you, there's two Y's on the scene here. How about the Y on the bottom? Is he unhappy?
No, he's happy.
He's happy. Happy camper there. And what does that mean? Is he going to jump or is he going to stay? He's going to stay. So the one on the top is going down and the one on the bottom is staying put. So both Y's end up on the bottom, don't they? The regular Y that was already there and now the other one is positive 9. And what's left on the top? We put a 1 whenever everything leaves. Is that good so far? So first do that. I haven't added or subtracted anything. I've just jumped. Make sense? Always do that first. Anytime. There'll be a bunch of negative powers on this test. So make sure you know that rule. Negative powers jump to the other side. Now let's think about adding, subtracting, that kind of thing. What am I going to do? Am I going to add or subtract or what? Yeah, because when they're side by side, this has a 1, doesn't it? When they're side by side, they add. So 1 over y to the 10th. And we're done. That makes sense? Negative powers jump. And then you do the add and subtracting. What if they'd both been negative? What if the one in the bottom was also y to the minus 1? Then he would have jumped to the top. Right? They would have both jumped. The whole fraction would have flipped upside down, huh? And then I would have subtracted because when they're vertical, you subtract. That's right. But that's always after the jump. Everybody seeing that? So don't try to add subtract first. Negative powers, let them jump. Get everything positive, then do whatever you need to do for adding or subtracting. All right. All right, try that one. All right, so what's the rule for powers outside parentheses? Powers outside, not outside. Yeah. Powers outside parentheses multiply powers inside. That's right. Only other powers. Powers outside parentheses multiply powers inside parentheses. Exactly. Powers with powers. So that negative 4 is going to go boom and boom. Right? Just hit those two powers. So that's just normal multiplication. Negative 4 times negative 1. Positive 4. Regular. You can just make it regular 4. And 2 times negative 4. Negative 8. So far, so good. The parentheses are gone. Whenever something from the outside of parentheses goes in, you drop them. So that's off. Now, what do I do with it? Can I leave my answer that way? Say, there it is. There's my final answer?
Nope.
No, they're never going to let us leave unhappy powers. They want us to make all the powers happy. So negative powers are unhappy where they're at. They're going to jump to the other side. So who's gonna jump?
Flip negative powers.
The B. The B is jumping down, right? So we end up having a to the 4th over b to the positive 8, and that's our answer. Is that good? Negative powers jump to the other side. Then they become happy, positive. Did you get that one? How you doing? Questions? All is well? All right. Let's try that one. So clean up that one. All right. So here we go. Let me hone in on you with this. I'm not hone in on you. Hone in on the problem for you. So the main. This is the one I wrote on the board because that's the main one. Negative. So first, negative powers jump and become happy, positive after the jump. Right. So that's the first thing. Let's go through and circle all the ones that are unhappy campers. This guy. Right? He's got a negative power on him. He's like, I'm unhappy here. Get me to the other side. This guy, he's got a negative power on him. Get me to the other side. Now on the top, it's only the b to the minus 2. Right? It's not the 7 or the a up there. They're happy. Everybody see that? Everybody see who's unhappy? Who has negative powers on them? Those are the ones that are going to jump. Everybody else is going to stay right where they're at. Let me bring it down. So the 7 and the a staying on the top, the b squared staying on the bottom. How about that? Those ones are staying put for sure. Right? All the other ones are going to switch sides, and when they do, they switch signs. They become happy, positive, right? So this guy's going up. You can put him on the left or the right. Doesn't really matter. Becomes 7 to the positive 1, doesn't he? This guy's going up. He'll become a to the positive 8, won't he? This guy's going down. He'll become b to the positive 2. Doesn't matter where you put him, left, right, order. Just top, bottom. Everybody see what happened then? The 7 minus 1 went up. 7 plus 1, a minus 8 went up. A plus 8, right next to that other a that's already up there. And the b minus 2 went down. We good? Good. So, and now, can you finish it from there? All right, what are we going to do? So what happens with this 7 to the 1 next to the other 7? Yeah, 7 times 7. 49. And what about a next to a to the 8th? Yeah, when they're side by side, powers add 1 and 8. 9. And what happens on the bottom? B2, B2. B4. Powers add. Side by side they add, huh? If they're vertical, they subtract. But that's all after the jump. What's that?
Over there you can have used also the 7 squared, A9.
Right, it is 7 squared. You're right. Yeah, 7 squared, they probably make it 49. 7 squared is 49. Yeah, but you're right. You're totally right. Is that good? So did you get that on your own? So there's a difference between after I do it saying, oh yeah, that makes sense, versus doing it on your own before I do it, right? So you want to speak the truth to yourself and resist the temptation to tell yourself sweet little lies. Because if you tell yourself sweet little lies, who's fooled? Only you. The truth will come out, right? On Thursday about what you really know. So say to yourself, if you didn't get that on your own, say to yourself, I don't know it yet. I need to try another one of those. Once you can get it on your own, then it's your baby, right? Then you've really got it. So strive that way. Write in SN. Scientific. So how do we write a number in scientific notation? Yeah, the decimal after the first digit, huh? So you got to put the decimal after the first digit. So 1.63. Does that make sense? Times 10 to what power? Yeah, you got to give it instructions to go back where it really belongs, huh? Where's the decimal really in the 16,300?
Like at the end?
Yeah, at the end, huh? It's really at the end. It's like a period in a sentence. If you don't see it, you know where it goes. It's at the end. Yeah, so when we put it between the 1 and the 6, that's not real. That's not where it really goes. So if you put it there artificially, it would need to go 1, 2, 3, 4 to the right. 4 power. That makes sense? So that power on the 10 makes it go 4 to the right. You know, because when you multiply by 10, a decimal goes 1 to the right. So if you multiply by 10 4 times, 10 to the 4th, it's going to move the decimal 4 places to the right, isn't it?
So do you always put the decimal after the first number?
Yeah, that's the very definition of scientific notation. That's how they defined it. They could have made it different. They just said decimal after the first digit. Is that good? Does that make sense? So I'd encourage you to be making your 3x5 card right now. Have a piece of paper. 3x5 card, and then just write the things you're going to want to know, like the definition of scientific notation, for example. Is that something you need? Then I don't know. It's going to be different for each of you. What you need, what's going to be helpful. So write that on there, if you want. All right. Let me write it bigger for you. So number 9. So 4 times 10 to the minus 4. 20 times 10 to the 5th. So find an answer like a normal decimal. Just use your calculator, in other words. If you know how to do all that, or you could move stuff around it. Do whatever you want. You do some calculator, some by hand, whatever is easiest for you. You can get on your calculator.
Yeah. Oh, it's going to decimal? Okay, it's 0.20. 0.20 times 10. That's it.
What'd you do with those 10s? Tell me about those 10s.
They're right here.
No, I mean the 10s.
Yeah, to the minus 4 power, to the 5th. I just subtracted. Oh. Thank you. So 20 times.
Okay. So what do we do first? What do we do first? Negative powers always first jump. Right? Are you getting the hang of that? I mean, there are other ways you could do it, but I think it'll be way easier for you if you first jump the negative powers. So this guy's like, I'm unhappy. He's jumping down, huh? Remember, always do that first. Whenever you've got negative powers, first let those guys jump to the other side, then they'll be happy. So then what do you got? We got 4 on the top, 20 times 10 to the 5th, times 10 to the positive or regular 4 now, huh? He's happy down below. He's positive. Is that good so far? Right? Why would he jump? He doesn't have a negative power. He has a 1 power. Does that make sense? Only the item with the negative power jumps. Only the 10 to the minus 4. Is that making sense? So negative powered items always jump to the other side. First. Do that first. Let them become positive. Now, what are we going to do from here? You can just do calculator if you want at this point. I mean, you don't have to do it anymore by hand if you don't want to. If you want to do another by hand step, that's okay too. I could do that for you. 10 to the 5th, 10 to the 4th. What are they going to do? 10 to the 9th. You don't have to do that, though. At some point, we're going to need to use our calculator. You can use your calculator at any point you're comfortable with. So you can do it back here, or that's a little cleaner if that's helpful to you. At some point, you need to go to the calculator. And so the answer, let me go to my calculator.
What is
9 zeros and a 5. Did you get that in your calculators? So that's just what your calculator should tell you. If not, it's lying to you.
What did you put into your calculator?
Yeah, it's hard. It's different on every calculator. That's why it's, I'm just got this little silly cell phone thing. It's different on different calculators.
What if you have like a super basic calculator?
Yeah.
You got the 5.
Okay. Yeah, I'll show you. Here, let me take you to a fresh screen. So 4 over 20 times 10 to the 9th. Okay. So what I would suggest doing is to do the denominator first. Figure out that denominator. 20 times 10 to the 9th. It's 20 and then 9 zeros. 2, 3, 2, 3, 1, 2, 3. Boom, boom, boom. 20, whatever that is. Billion, I think. Anyway. Right? Did you get that? Okay, does that make sense what I did there? This 10 to the 9th is just 9 zeros. It's 20 with 9 zeros, isn't it? You aware of that? If I write 10 squared, what's 10 squared? 2 zeros. It's 100, huh? 10 times 10 is 100. So if you write 10 to the 9th, it's 9 zeros. Huh? Is that good? So far, so good? You just use your calculator. Just go 20 times 10 to the 9th. Do you know how to do the power button on your calculator to get that 10 to the 9th? Do you have a calculator that does that? Yeah, right. Oh, so it writes it that way for you, huh? Yeah, that's good. That's fine too. And now, you get
my calculator. When I put 20 times 10 to the 9th, I get
2.
I use simple 10. It does 10
minus 10.
Yeah, it's writing this, right? It's writing 2, 10, 10 like that.
Yeah.
That's the same thing, right? No?
2, 3, 4, 5, 6.
9 zeros and 1 more. That's got to be 10. All right, so I know. All right, so that's another way to say the same thing. So, but we're not done yet. Hold with me. So if you've got that answer on your calculator, then go 4 divided by, and do you know the answer button? This is where it's a little tricky because every calculator is different. Do you know where the answer button is on your calculator? Usually in the lower right corner. And you usually have to hit second and answer, but not in every one. That's why I'm kind of struggling to say it because it's different on every calculator. So first do this thing. Get however your calculator wants to say it. There's several different ways. And then go 4 divided by answer equal, and you should get that. Oh, but it's going to write it in scientific notation again, isn't it? It's going to write, what is it going to write? 5, let me see, I bet I know what it's going to write.
Oh, answer what you want.
10 minus 10. Yeah, that's what it's going to write. Yeah, sorry, there's all this scientific notation. I got to tell you how to discern that at some point. You guys getting that? This is the answer you should get if your calculator forces it into scientific notation. Are you not getting that? All right, so let's go through these steps. Let's go slowly through these steps. Times 10 to the minus 10. Yeah, sorry about that.
Tears right now.
There it is. 2 times 10 to the minus 10. All right, so let me and Shelby change my approach. So yeah, do this. Just from the very beginning. Let's just do it from the very beginning. So here's number 9. What was it? It's 4 times 10 to the minus 4. 4 times 10 to the minus 4 over. 20 times 10 to the 5th. Yeah, do this. Just type it in. Don't even do any steps at all. But you do have to use parentheses. So literally just type in the top 4 times 10 and then hit your power button. Your power button is either the up arrow or the X to the Y, depending on which kind of calculator you have, to the minus 4. And negative, On the TIs have a problem with negatives. There's a difference between the negative button and the subtraction button. Casios don't really care a lot.
No, the Casio has a button that says X minus the one right here. It's minus already. You can.
Okay, great, yeah. So watch out, don't use the subtraction. -4. Oh, but I forgot the parentheses. So I should have had parentheses, and then go divided by, and then parenthesis, 20 times 10 to the power, or x to the y, however your power is, 5, parenthesis, equal. Type in exactly that, and it'll work. Does that make sense? I just parenthesized the numerator and the denominator.
That's how I did. I just make from the very beginning.
Yeah.
And then give me the answer.
Yeah, good. That's great. Yeah. That's always right, because the Casios can make a nice little fraction. Oh yeah. So I'm sorry. This is what's hard. Every calculator is a little different. If you have those nice Casios that show it like a fraction, you don't need the parentheses. It's all good. It's just for the cheaper ones that don't show the fractions. Sorry, I mean this is the problem. Every calculator is a little different. So if you have
The other
a
brands, the
Casio,
other brands. Generic brands. Hey, well, this is what it is.
but it just does it sideways. Yeah, no, you're gonna have to do the parentheses. Yeah, I mean it actually shows it vertical.
I thought you were
You'll
using
do- Yeah, those are parentheses. Yeah. I still haven't shown it. I still want everybody to get a page. Yeah, I gotta explain. So, are we getting it? We still haven't wrapped up this problem. It's good. We're gonna spend all night on this problem. 2 times 10 to the minus 2. Now that isn't the actual final answer. I got to show you how to turn that into the final. But that's what your calculator gives you at first. Are you getting it to there so far? Are we able to do that? So if you have the nicer kind of calculators where it shows a fraction actually vertical, one thing over another with a bar. If it does that you got a nice one. Hold on to that. You don't need to mess with the parentheses. Not required. The parentheses are only needed for those that have the calculators that put everything on one line instead of showing top and bottom. Then you have to have parentheses or the calculator won't know what's top and what's bottom. Is that making sense? So if you have the nice calculator that shows top and bottom, don't need the parentheses. But if you have the calculator that shows it all on one line, then you need to parenthesize the numerator and denominator so it knows what's the top and the bottom. So one way or the other, you're able to do that and type that in and get 2 times 10 to the minus 10? Because I'm going to lead you forward to the actual answer. Because that's not it. But that's almost it. Are we good? We getting that? We all on track? All right, so why is that not the actual answer? Well, they want a decimal answer, I believe, on this question. Let me make sure. Yeah.
It's in front of the 2.
It's right there, behind the 2. Right? Remember, it's like a period in a sentence. If somebody gets put the period on, you know where it goes. It goes at the end. And then what's this 10 to the minus 10 tell that decimal to do? Go back 10 places, huh? The first jump, it gets to the edge. The other 9 jumps bring in zeros. So the real answer is a decimal point. Is a decimal point, 9 zeros. 1, 2, 3, 4, 5, 6, 7. I'm just spacing them out so you can see it. And then the 2. You don't really space them out like that, but I'm just trying to be clear. That's the actual answer they want. Does that make sense? We good on that now? Do you know how to operate your calculator? It all depends on which kind you have. If it's all on one line, then you got to parenthesize. Numerator and denominator. All right, I'm going to move on from that problem if you're good. All right, so try number 10. Can you see number 10? Maybe I better write it out for you. 6x squared y. So number 10, 6x squared y. Plus 9xy squared. minus 6yx squared plus 6 minus 6 y squared x. Okay, it just wants you to gather like terms. So you can do that one with the greatest of ease. Remember, the order doesn't matter, right? So 6yx squared, that's the same as 6x squared y, huh? The order doesn't matter. They're trying to fool you with that. They're trying to switch the order on you. These guys just cancel, don't they? They're the same thing. Right? 6 of them minus 6 of them. And these guys are the same thing also, aren't they? They both have the square on the y, not the x. We good? So 9 of those, take away 6 of those, is 3 of those xy squared things, plus 6. Done.
And you can write it the other way too, right? Like
Put 6 in the front?
Y2.
Oh, yeah, you could write, 3y2x, yeah. It'll be multiple choice on the real exam. We good? All is well?
So it doesn't matter.
It doesn't matter. Order doesn't matter. Yeah, okay, so try the same kind of thing. Combine like terms, right? Any terms that match, we combine them.
11,
So that's
Can you hold that door and fan us? I'm kidding.
you again.
So we don't do anything with powers, do we? When we're adding, subtracting, we just do the numbers in front. We don't mess with powers, huh? When do we change powers? Multiplying or dividing, right? Multiplying, we add powers, dividing, we subtract powers, right? Get those rules down. We'll try to run through this thing one more time. Let's see. We're going to run out of time.
I like terms.
We'll get stuck on number 9.
I know, I was like, we'll get stuck on that problem.
So,
I'll give the wrong answer, then give 3 or 4 different technical
Just take
explanations.
it out of the test.
You're taking out of our test time.
Or you just take it off the test altogether.
Right.
All right.
Since you got it wrong too, you should just take it off.
That's right.
Let's vote.
13y cubed. 9. So then 9a squared b squared minus 17. A squared b squared. So 9 minus 17. What's that? Minus 8. A squared b squared. And then minus 6 minus 15. Minus 21. Good? Easy enough?
Yeah.
You can just have a whole bunch of these.
Yeah. These are the easy ones. I told you the top 9, first 9 were the hard ones.
Just take number 9.
All right, I'm going to move on if you're all good. Try that one. That'll be easy. What do you do when there's a minus in front of a parenthesis? Distribute. So all is well. Does that make sense how we did that? So I just distributed that minus through the right side and then gathered like terms, and the x squared's all canceled, huh? All right, we good here? So this minus is going to distribute. Then we gather like terms. 5x squared minus 3x squared. 2x squared. 7y squared. Oh, these cancel, don't they? And then minus 4 plus 2 is minus 2. Good? These are your favorite ones, right? All good? Everybody good? I just distributed the minus. A couple things canceled. There we go. This is minus gets in. That minus hits all three. Changes all three sides.
They give me 86.
We all good? All right. All right, we good? This one making sense? Let me make it a little bigger here. Number 14.
We go to the 14. How many questions are 20?
20. You only get a half an hour on the test. I'm kidding.
Oh my God. X2.
Okay, so the half x squared is going to multiply all three, right? So it's going to go right here first. So what's half of 8? 4. And the powers do what? Add 4x to the 4. So far, so good? Out front numbers multiply, powers add. So he went there. Now he's going to go to the middle guy. Half of 6? 3. It's negative, huh? Negative 3. And the powers add. What powers on this one? 1 and 2? 3. Out front numbers multiply, powers add. Okay. And then it goes to the back one. Anything times 1 is just itself, huh? Half x squared. There we go. That's it. Yeah, we can't add or subtract any of those further. Why not? Because they're different powers. Yeah, they're unlike terms, huh? Yeah. Is that good? See how the powers added there, right? So when we multiply is when powers add. Right? Whereas back here, like on number 13, no powers added. When I was doing 5x squared and 3x squared, the powers didn't add. They just stayed the same, huh? So when you're adding, subtracting, powers stay the same. When you're multiplying, that's when powers add. Okay? All right. Let's keep going. That one. So it's a multiply because the parentheses. So you first do the x, right? They take turns. First the x is going to multiply all three. And then the minus 6 is going to multiply all three. So take turns there. It's going to be 6 multiplications. So this x here is going to go to all three, right? You guys getting that to happen? So he's an x to the 1 power, isn't he? So he's going to add powers. Here we go. X. What happens with x to the first times x squared? Powers add, yeah. And then he goes to the middle guy. That's a minus 3x squared. We good there? And then he goes to the 4 at the back. 4x. He's done. You can cross him off. You don't have to, but I'm just making note that he's done. He went to all three. And now the minus 6 is going to go to all three. Minus 6 times x squared. Negative 6x squared. Minus 6 times minus 3x. Two negatives. Positive 18x. Is that good? And then minus 6 times plus 4. Minus 24. Did you get those 6 terms? Out front numbers multiply, powers add. Now we go into like terms, huh? So just start with the highest power. So I'll just start with x cubed. You can circle them, underline them, cross them off, whatever. So x cubed first. Next, do all the x squareds. So minus 3x squared and minus 6x squared. Minus 9x squared. And then the regular x's. 4x and 18x. 22x. And then the minus 24. There we go. Is that good? Questions on that? Doing good? All right. I'm going to keep moving. Okay, try that one.
What does it mean when it says multiply vertically?
Yeah, ignore that.
Oh, okay.
Yeah, it just means it wants you to put them vertical, but who cares? It doesn't know what we did. Just multiply right regular. Oh, I didn't use the Manuel line them up method, did I? So you can do that if that helps you. All right, let's try this one. So the 7x goes to both, right? First to both, second to both. So what happens with 7x times 4x? 28x squared. Oops. Right, 28x squared there. Plus 7x times 1 is just 7x. He's done. And then the minus 11 will go to both. Minus 44x minus 11. Good so far? And now, can we gather any like terms? Yeah, these middle two, huh? So this will be 28x squared. What's that? Minus 37x minus 11. There we go. Easy? All right. So these are that one. 3x minus 4y squared. All right, we're going to write two of them. Okay. And then the first one goes to both. 3x, 9x squared. Then 12xy, he's done. And then the second one goes to both. Minus 12xy plus 16y squared. Did y'all get that part okay? Okay, and then these middle two, like terms, they will combine. So we get 9x squared. Oops, come on. Minus, what's in the middle? 12xy, 12xy? 24x squared, y squared. Is that right?
No.
Right, it's just xy. We don't mess with powers when we're adding, subtracting, huh? We just do the numbers in the front. You only do powers when you're multiplying, right? Just want to keep making sure that's clear for you. And there we go. Good. Questions on that? So it's those first 9 are the issue. Right, let's see it. And so make it 3 separate fractions. Oops. So 3 separate fractions like that. And then we cancel things, don't we? So 5 goes into 10 2 times. And what do the powers do? Subtract. Minus 2x squared. I don't know why my pen's suddenly wigging out here. Okay, plus 5 goes into 30. 6 times. Subtract the powers. X to the 1 or just x. And now what happens at the back here? 5 goes into 15 3 times. And take the baby. Not if it's not your baby. All right. So it's, we could be tempted to write that, but that's not correct. What's wrong about that?
It's on the right spot.
Yeah, the x to 4 is supposed to be in the bottom, huh? It can't suddenly jump up to the top unless it was a negative power and unhappy, but that's not what's going on here. Like that? That good? Watch out. I know I've seen the way they write these tests. They like to try to sucker you in with a bar that goes all the way. That's not right. On the multiple choice, you know, the bar only goes right there, huh? Is that good? One more of these, and then so 20. Skip it. Don't worry about it at all. Just stop at 95%.